Day two of at least probably 4, 3, 4, I don't know, we'll see, probably 4 days of section. This is really section 5 and 7, 6, or 7. This is really 3, 5 and 3, 6 kind of mold together a little bit. We'll just keep calling it 3, 5 because I'm too lazy to change it. So today we're still going to continue working on factoring polynomials. I'm going to show you how we go about factoring a polynomial. If it's 4 terms, sometimes you can get away with using a box method to do these. Sometimes it doesn't work all the time, but it works sometimes, and when it works, it's kind of slick. Makes things a little bit quicker. So we're going to start out by looking at those. Then we'll go into a little bit of a review from yesterday. So those of you that were gone yesterday, kind of get you on board a little bit. But then there's going to be more to it now. It's not just going to end. We're going to have to factor other parts again. So we're going to have to look for factors within a factor type of situation today. We should be able to roll through it relatively quickly. We're probably next Wednesday, maybe Thursday at the latest for your test over chapter 3. We'll see how next week goes, but earliest to be Wednesday, latest to be Thursday for the test. So if you have 4 terms, so one of the things you can try if you have 4 terms is you can try factoring it by, and you're asked to factor, you're asked to find the zeros, whatever it is you're asked to do. In this case, we're just going to factor these two. Anytime it has 3 terms and you're asked to factor 4 terms, one of the things you want to try is you want to try using what we call the box method. The box method is just kind of a shortcut way to see if something factors or not and try to factor it. So we create a box, ladies. So we create this box, and we did the box method when we were multiplying polynomials. And we're just going to kind of do the opposite. Instead of having the stuff on the outside now, we know what the inside's going to create. The inside's going to create m cubed minus 2m squared minus 7m and 14. That's what the inside part of it's going to create. What we want to figure out is, okay, what two, in this case, 2 binomials do we have to multiply together in order to get these? Now, this doesn't always work. You always have to check these because sometimes it doesn't work. And if it doesn't work, you've got to do it in a different method. But it's not a bad method to try, and sometimes you can just see that it does work. So in order to do this, what we do is we look at this first row, and we take a GCF of the first row. The GCF of the first row, m cubed and negative 2m squared. GCF is m squared. Okay, that's just the GCF of that first row. Now I can fill the other spots in. I can fill these other spots in by kind of using the multiplication pieces of it. Okay, so what I'm thinking of is okay, m squared times what is going to give me m cubed? Well, obviously that's just m. So I'm going to put an m there. So m times m squared is m cubed, so that works. And now I've got this m sitting up here. Oh, I lost my m, didn't I? That m is supposed to be there, I just didn't write it. That m is there. Okay, so that m is sitting there. Now, to get from m to negative 7m, I have to multiply that by negative 7. Now, that negative 7 is also the GCF of negative 7m and 14. So really, all these are the GCFs going across your rows. All the columns are going to be is the GCFs of your columns. Now you'll notice this is negative 7. If you're doing the GCF model to do this across the rows, if the first term that you come to is negative, that negative has to go with it. because m times negative 7 needs to be negative 7m. So we've got our first factor done and taken care of. Now if we want to take care of the second one, we can do it one of two ways. We can do m squared times what is negative 2m squared, or what's the GCF of negative 2m squared minus 14. And either way you go, you end up with negative 2 as your solution. So factored form for this then is m minus 2 times m squared minus 7. And that's the factored form of that polynomial. Now we could go on and we could find the zeros for that. We could graph it. We could do all those different types of things. But what I want you to see, at least in these first two examples, is I want you to see just a different method that can be used to factor cubics, okay, that have 4 terms. Again, it doesn't always work. And it doesn't have to be cubics necessarily either. If it has 4 terms, you can always try it. But again, I caution you that you got to make sure it works. That's m cubed, that's that, and that's that. So we're good to go. So we know we have it, but you got to check while you're doing these. Okay? Why don't you go ahead and do that one, factor that one using the box method. And again, you're just factoring it. You're not going to graph it, just factoring it. You don't need to find the zeros, just factor it. Looks like it works. So you should have got 3a squared minus 8 and 4a minus 7. If you turn it around, that's fine. And again, all we're looking for is GCFs. And again, if your first one that you come across, like with the negative 8, negative 32 is negative, so that has to be negative. 4a times negative 8 is negative 32. So, works. Questions if it's 4 terms? We good there? Again, always try it. Might work, might not. If it doesn't work, you got to try a different method. Okay, those different methods are the methods that we talked about yesterday. So yesterday we talked about how do we go about graphing, finding the zeros and graphing polynomials of any degree, especially if you're given a factor or if you're giving a root. Today we're going to be given a root for some of them. You'll also be given a factor for some of them. But we're going to go through the process again just to kind of make sure everybody's good to go. So we're going to take this, and we're given that x plus 5 is a factor of it. We want to find all the zeros, find the multiplicity of each of those, and then degree, which we could do right now, and then we're going to graph it. Okay, so we're going to take this kind of all the way from the beginning of what we did yesterday. So those of you that were gone can have an idea of exactly what went on yesterday. So we're going to use synthetic division to do this. Telling us that x plus 5 is a factor. So if x plus 5 is a factor, what goes inside the box? Negative 5. As again, remember the factor. We set the factor equal to 0, and that's what goes inside of there. And now we just go with the coefficients that are out in front of our variables. So we've got 1, 5, negative 25, 4, and 20. Now we're going to do synthetic division with all hopes that that is 0 down there. It should be. If it's not, we've done something wrong. So we've got a 1, we've got a -5, we've got a 0, we've got a 0, we've got a -5, we've got 25, we've got 0, 0, 4, -20, 0. So it all works. So that's good. So our first factor of this is x plus 5. That's the first factor. The second factor, this is going to be x to the, what power? How do I get this second factor? X to the 4th minus 5x to the 2nd plus 4. Okay, so there's our other factor. Now, we're going to set this equal to 0 because we're going to find the zeros and we're going to graph this thing. But now we've got this trinomial sitting in here. Okay, since we've got a trinomial in here, and it's actually to the 4th power even, we need to see if that actually factors or not. 3 terms, as long as your a squared, your x squared, as long as that's a perfect square and that's half of it, you're okay. It doesn't need to be a perfect square. As long as it's even and that's half of it, you might be able to do it. So we can try the x method. So if we try the x method with that, it's still the same thing. We've got 4 and -5. So the top is positive, the bottom's negative, so these are both going to be negative. So you've got -4, -1. So this gives me x plus 5. Just bring that along. Now this in blue is become what my power of my x value. This needs to be squared. Because I started with the 4th, all I've done is taken what was in blue in our first one and I've rewritten it in factored form. Is it done? Nope. Nope. These two blue are still in. Now, it's not done being factored. Could you find the zeros from this point? Yes, you could. But let's take the factor one more step. X squared minus 4 is a difference of squares. So that's x minus 2, x plus 2. X squared minus 1 is a perfect square. It's x minus 1, x plus 1. Okay. Now it's completely factored. I look over each piece, make sure it can't be factored. It can't be. So we know we're in good shape. Now we're going to find the zeros. So remember we talked about yesterday, it's what makes each individual piece 0. So my zeros in this case are going to be -5, 2, -2, 1, and -1. Each of them have a multiplicity of just 1. Each of them only happens once. What degree is this? 5th. And you could do it by adding up the multiplicities or just look at the original problem. It's a 5. Leading coefficient, again, just look at the original problem to figure out if it's positive or negative. It's positive. So when we graph this, it's odd and positive. So odd and positive is our end behaviors are in the 3rd and 1st quadrants. Now if we graph the points, we've got -5, 2, -2, 1, and -1. Okay, again, we're just sketching it. So our graph starts down in the 3rd quadrant, or we'll start it down in the 3rd quadrant, goes up and through -5, down and through -2, up and through -1, back down through 1, and back up through 2. So your graph looks something like that. And it goes through all the points because their multiplicities was odd. Okay, I don't know if nope, I didn't do that one. Questions with that one? We okay? Okay, let's look at the next one. Okay, so you've got x to the fifth minus 2x to the fourth minus 9x plus 18, given that x minus 2 is one of the factors. But we're also given that there are 4 terms. Which way you want to do it? 4 terms. We could try the box method to see if it works. If we use the box method, we don't have all that synthetic division, right? Let's see if it works. We've got x to the fifth, negative 2x to the fourth, negative 9x, and 18. This would be x to the fourth, right? That makes that x. This would be negative 9. That's negative 2. Box method seems to work, right? Okay. And it showed us that one of the factors was x minus 2. So the box method worked on this one. I see no reason why you wouldn't do it. It's a whole lot faster than doing all that synthetic division and messing yourself up probably because there's a 3 and a 2 there. So, it worked. Now, again, we got to ask our question. We've got x minus 2. We've got x to the fourth minus 9. Are we done? No. This x to the fourth minus 9, that can be factored further. So we've got x minus 2, x squared minus 3, and x squared plus 3. Difference of squares. X squared is a perfect square, but 3 isn't, so we can't factor that any further. So it's done being factored. So we find the zeros. First 0 is easy. First 0 is just 2. First 0 is just 2. Second one, not so easy. X squared minus 3 equals 0. X squared equals 3. So the square root of 3 and the negative square root of 3. And then x squared minus 3 equals 0. Or sorry, x squared plus 3 equals 0. So x squared equals negative 3. So that would be I radical 3 and negative I radical 3. Everybody see how I got the zeros? Square root of negative 3 is I radical 3. Multiplicity on all of these things. It's all just 1, right? Okay. So if we graph this, and we're going to graph these today. Yesterday I had you not graph the one with eyes. Today I'm going to have you graph the ones with eyes. So we've got zeros. We only have 3 real zeros, though. So we're talking about with real zeros, or we're actually numbers. 2, radical 3, and negative radical 3. Those are, I can make them into decimals. I can put them on the x-axis. These are imaginary numbers. Imaginary numbers can't be put on the x-axis. Essentially what these means, they're going to be a turning point with these. So the graph is going to go from up to down or from down to up at some point in time and over some interval. We're not going to discuss where that interval is. We're just going to worry about the real ones, and then I'll show you on Desmos what the other one looks like. So 2 is right there. Square root of 3 is right there. The negative square root of 3 is right there. It's a 5th degree and positive. So the graph is going to come up. It's going to go through negative radical 3. It's probably going to do something up there, but we don't care. We're just going to bring it down and go through radical 3, and then we're going to come back and bring it back up through 2. Okay? And again, there are more turns in here with these imaginary pieces. But we're just going to graph only the real parts. These are kind of considered to be our real zeros. It's got 3 real zeros in it. And I want you to do this one yourselves. Given this time that -2 is a root. So this one, -2 is a root. I'm not giving you the factor. I'm giving you that -2 is a root or a 0. Same thing. Go ahead and factor it completely. Find the zeros and sketch the graph. Okay, it's up there. The graph part, whatever. Finding the zeros. That part should be good. Just be the graphing part that I'll show you what the actual graph looks like.
Yeah, where's the 1? You read that? I want to feel.
It doesn't bounce off, it only has multiplicity of 1. It just goes through it. I'll show you what the actual graph looks like.
How do you have no curiosity at all?
Questions?
It's just greasy.
No, it's just minus 3.
I feel like it's standing.
-9.
It's so smooth that it feels like it's almost greasy. Feel.
Oh, I didn't say. I
Really
didn't.
smooth and greasy.
Yeah.
Feel
Good?
my
All right, actual graph. This is what the actual graph looks like. Polynomials. This is what you're going to deal with today within your assignment. First few are going to be 4 terms. If it has 4 terms, try to do the box method. If it works, great. If it doesn't, you have to use this method. Second part of it, they're going to look like this. Okay, I don't think any of the directions tell you to graph today. I think all the directions just tell you to find the zeros. You need to do 10 of them. And do not do the last 2. The last 2, that's what we'll work on Monday. On Monday, you're not going to be given any roots or zeros. We're going to have to find them. That'll be Monday.